Hey guys, Miss Miklos here with the Pre-Calc Chapter 11 review video. And I'm only going to go through a few questions, but I am going to choose some that are actually on the review worksheet. And the first thing I want you guys to do is take out your graphing calculator. Definitely make sure as I'm going through this, you guys are using your graphing calculator. Towards the end of the video, I will do some stuff with the graphing calculator to make sure that you're feeling okay using that. But I want to start with finding limits using a table. And first thing, if I were you right now, and make sure that your calculator is in radian mode. Because if we go through anything like number 2 where we have a trig function, I definitely need to be in radians. So there's a few different ways that we could do one like number 1. Using this table, here there are values that are already given to me. So really all I'm doing is I'm substituting in this x value wherever there's an x, and I'm going to come out with a y value. Another way that we could do this is by going through and actually graphing this function and then using the trace mode and finding the x values that correspond here, and it will give us the y values. And towards the end of the video, I'm going to show how to do that with our graphing calculator. Okay, so I'm going to start by figuring out what is our y value when x is 1.9. So when I go ahead and substitute this in, when I put in 1.9, I end up getting 0.12987. When I put in 1.99, I end up getting 0.1255. When I put in 1.999, I end up getting 0.1250. Okay, so it appears that the limit of f of x as x approaches 2 from the left is getting close to 0.125. And I am viewing that just based on these values, it looks like it's getting really close to 0.125. Now I need to look on the other side because we know a limit only exists if they are both going to the same number from different directions. So when I put in 2.1, I get 0.12048. When I put in 2.01, I get 0.124533. And when I put in 2.001, I end up getting 0.12495. So once again, it appears that the limit as x approaches 2 from the right is also going to be 0.125. So for me, I would say then the limit as x approaches 2 of our function f of x is 0.125. Now keep in mind, problems like this are on the multiple choice, so there would be different ways to go about doing this, and I'm going to talk about how to use the table function in our graphing calculator later on. Okay, moving on, I want to talk about finding the limit using a graph. So I'm focusing on number 3 here. So the first thing that I want to do is graph this function in my graphing calculator. Remember, if you press second 0, that gives us the catalog where absolute value is an option. So I'm going to do the absolute value of x minus 3 over the quantity x minus 3. So just a reminder that when I put this into my graphing calculator, I do need to use parentheses in the denominator. And when I graph it, it looks something like this. And just to quickly review what this means, looking at this graph, I want to know what y value does it look like we're approaching when we hit an x value of 3. So first I need to look from the left. The limit is x approaches 3 from the left. If I'm going along this line, if I kept going, it looks like our y value here is going to be -1. Then I need to look and see what is the limit as x approaches 3 from the right. And if I'm looking at this line as I approach from the right, it looks like our y value is going to be positive 1. Now when we compare these two different one-sided limits, I notice they are different answers. So our answer is going to be does not exist, and our reason why is going to be that the one-sided limits do not match. So the one-sided limits don't match. And that would be our final answer. Moving on to number 6 here, I'm actually going to do this one algebraically. And I just want to focus on the fact that this one is a piecewise function. So we're trying to find the limit as x approaches 2 of f of x, where to the left of 2, the function is 5 minus x. To the right of 2, the function is x squared minus 3. So I'm going to go ahead and figure out what are our one-sided limits. So the limit as x approaches 2 from the left would be 5 minus 2, which is 3. And I got that from substituting into this first equation. I knew this was from the left because it said this function is true for x values that are less than 2. The limit as x approaches 2 from the right would be the function x squared minus 3, because that's when x is greater than 2. So I'm going to say 2 squared minus 3, so 4 minus 3, which is 1. So once again, this is a case where we would say the limit as x approaches 2 of f of x does not exist. And if we had to state why, once again, we would say the one-sided limits do not match. So I'm writing don't match. Before we move on to using some algebra, I wanted to look at one of these problems where we're using the graph. So in this case, the graph is already given to us, and there's going to be some on our test that are similar to this where you are actually given a graph. So if we look at this, we can definitely see that there is a hole in the middle of this. Okay, but regardless, the whole point here is I need to see as we approach 1, so as we approach an x value of 1, does it look like we are going to the same y value? And from the left, it appears that we are going to a y value of 2. From the right side, it also appears that we are going to a y value of 2. So even though this point does not actually exist, okay, we can see that from both sides of the equation, that is where it's leading. So we would say our limit is 2. Okay, so we are moving on ahead to algebraically. And the first method that I'm always going to try and use is direct substitution. So if we look at number 1 here, I'm going to do the limit as x approaches 4, and I'm going to go ahead and substitute in 4 for x. And in this case, I get 2 plus 3, which is 5. So our answer here, technically we should write the limit as x approaches 4 of 1/2 x plus 3 equals 5. And I would always try and use direct substitution first. When direct substitution does not work, remember, is when we get 0 over 0, which we call indeterminate form. So let's look at number 4. If I put negative 2 in, I get negative 2 plus 2 over negative 2 squared minus 4, which is 0 over 0. Okay, and we know that this is not good. We need to go ahead and use the dividing out method. So what that means we're going to do here is I need to see, can we factor the numerator, can we factor the denominator? I know the numerator is x plus 2. The denominator I can factor to be x plus 2 times x minus 2. These x plus 2's cancel out, and I know that the limit as x approaches negative 2 of 1 over x minus 2. I can go ahead and use direct substitution now and substitute negative 2 in for x, and I get 1 over negative 4. So we would say the limit as x approaches negative 2 of x plus 2 over x squared minus 4 is negative 1/4. And that would be our final answer. Next, I want to look at number 8. And number 8, if I put 0 in, I would get 0 over 0 again. So since we have this radical, this is when we used our rationalizing technique. So I'm going to multiply by the conjugate, which would be the square root of 4 plus x plus 2 over the square root of 4 plus x plus 2. So when I go ahead and FOIL, I get 4 plus x minus 4 over x times the square root of 4 plus x plus 2. I notice that these two 4's cancel each other out. And then we can reduce those x's. So I really have the limit as x approaches 0 of 1 over the square root of 4 plus x plus 2. And at this point, I'm going to go ahead and substitute in. And I ended up getting 1 over 2 plus 2, or the limit as x approaches 0 of the square root of 4 plus x minus 2 over x is equal to 1/4. So that would be our final answer. If we look at 9 and 10, these are just helping us know our properties. And remember, a lot of our properties were common sense. For example, it says the limit as x approaches c of 4 times f of x minus g of x. We learned that we can go ahead and split this up to be like 4 times f of x minus the limit as x approaches c of g of x. And we learned that if we have a constant, we can go, or I should say a coefficient, we can go ahead and factor that out. So I have 4 times the limit as x approaches c of f of x minus the limit as x approaches c of g of x. Now, the really nice thing on this problem is they tell us these two limits. The limit as we approach c of f of x is 5, and the limit of g of x, it says, is 2. So I end up getting that our answer is 18. Okay, I'm going to do number 10 also. This time, I can do 5 over 2 because I'm splitting up the limits. The limit of f of x is 5, the limit of g of x is 2, and that would cause a ratio. Limits at infinity. Okay, we are going to show all of our work, and it's good for us to kind of remember our shortcut also. So I'm going to go ahead and look at number 1 here. And number 1 says the limit as x approaches infinity of 2x divided by x squared minus 25. Kind of the long way we talked about doing this is finding the highest power in the denominator and dividing everything by it. So I'm dividing everything by x squared here. And then I can simplify this, and it becomes the limit as x approaches infinity of 2 over x over 1 minus 25 over x squared. And using those properties that we just talked about, I can kind of split this up. I know the limit as we approach infinity of a number over x to any power is just 0. So this becomes 0 over 1 minus 0, which is 0. And you guys may remember our shortcut was when the numerator had the highest exponent, the limit did not exist. When they had the same exponent, we took a ratio of the coefficients. And when the denominator has the highest exponent, then we know our limit is 0. The next thing I want to go over is finding a derivative and the slope of a tangent line. Remember, those really mean the same thing. So we're going to start with number 1 here. And if it tells us that we have to use the limit process, which it will on the free response portion, then I need to know that I'm doing the limit as h approaches 0 of f of x plus h minus f of x over h. Now number 1 might look tricky because it says g of x, but I know that I'm doing the same thing. The limit as h approaches 0 of g of x plus h minus g of x over h. So off to the side, I need to figure out what is g of x plus h. And remember, all that means is that wherever there is an x, I'm writing x plus h instead. So I'm doing 2 times the quantity x plus h squared minus 1. So I get 2, and when I FOIL x plus h squared, I get x squared plus 2xh plus h squared minus 1. So I get 2x squared plus 4xh plus 2h squared minus 1. So I'm going to go ahead and write the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared minus 1 minus, and I know g of x is 2x squared minus 1, so I'm going to write 2x squared minus 1 over h. So I need to distribute this negative, and then I notice my x squared terms cancel and my 1's cancel. So I have the limit as h approaches 0 of 4xh plus 2h squared over h. I notice that I can factor an h out of my numerator. And the reason why that's helpful is then my h's cancel out. And now I can use direct substitution, and I can do 4x plus 2 times 0, which is 4x. And this asks us for the derivative, so our notation would be f prime of x equals 4x. Now, just a reminder that if it does not state that we need to use the limit process, we can always use the power rule as a shortcut. So I'm going to do that for number 3 here. So just to remind us, f prime of x, I move my exponent out in front, so I have 2 times 2x, and I drop my exponent down 1. So 2 becomes 1, plus 1 times 4, and x to the 0 means just 1. This negative 1, we know really has an x to the 0, but when I take this 0 and move it out in front, 0 times anything cancels out this whole term. So we would say f prime of x equals 4x plus 4. Okay, for number 16, I want to show us how we can find the slope at a specific point. The way that this problem is set up, it's telling us to use the limit process in A and then apply that ordered pair in part B. I'm going to do something a little bit different though. And on the multiple choice portion, if it just is a multiple choice question, you are more than welcome to do what I'm about to do. So I'm going to say the limit is h approaches 0 of f of x plus h minus f of x over h. And what I'm going to use this time is the fact that 0 is x and negative 1 is f of x, because I know that's my y value. So I'm going to say the limit is h approaches 0 of f of 0 plus h minus negative 1 over h. So I know this is really, if I wanted to think about it, just h, because 0 plus anything is the other thing. And so if I am doing f of h, that means I'm putting h into this function wherever there was an x. So I get 2h squared minus 1 plus 1 over h, and this plus 1 came from this minus negative 1. My 1's cancel out, and I can simplify 2h squared over h just becomes 2h. Now, as that approaches 0, I can go ahead and do 2 times 0, which is 0. So that means that my slope at that specific point is 0. Okay, so that's how we can go ahead and directly find the slope at a specific ordered pair. And the final thing I'm going to do before we look at the graphing calculator again is finding the area of the region, and I'm going to go through number 3. So we talked about the way that we can do this. It is the indefinite integral from 0 to 5, and those numbers are coming from the interval given to us, of the function, which in this case is 5 minus x, and then I know that I need to write dx after our function. So remember, to find integrals, which is that capital F of x, what we need to do, I need to bump up the exponent by 1 and then divide by our new exponent. So I know 5 is like 5x to the 0, so this becomes like 5x to the first power divided by 1, minus x to the first becomes x squared, and I need to divide by our new exponent, so I'm putting it over 2. So I get that our integral f of x is 5x minus x squared over 2. So now in context of this problem, I'm doing f of 5 minus f of 0. And I'm getting 5 because that is the biggest number of our interval, and 0 because that is the smallest number of our interval. So I'm going to substitute these in. So when I put 5 in, I get 5 times 5 minus 5 squared over 2 minus 5 times 0 minus 0 squared over 2. So I get 25 minus 25 halves minus 0. So our answer would be 25 halves square units. So I know this was kind of brief, but hopefully it gave you a pretty good overview of how to do all these different types of problems. Now I'm going to spend a few minutes just talking briefly about the graphing calculator. Okay, so I wanted to take some time and talk a little bit about the graphing calculator. So I'm going to clear out my key history here. The first thing I want to talk about is graphing. So let's say we had something like the absolute value of x minus 3 over x minus 3. And we did that one on the review video already, because this is still the review video. So I'm pressing y equals. And to get to the catalog, remember I do second 0. And this very first one, absolute value. So I'm going to press enter. And yours might look like mine. It might not. Either way, it doesn't really matter. In this case, I was going to do x minus 3 divided by, and then I need to put in parentheses x minus 3. I cannot stress to you guys how important it is that we use parentheses properly. Now when I go ahead and do zoom 6 and graph this, we want to look at the one-sided limits as x approaches 3. So as x approaches 3 from the left here, I can definitely see our y value here is -1. As x approaches 3 from the right, I can see that our y value is definitely +1. So we would say that the limit does not exist. Next one I want to look at is number 2 on the worksheet, where it says the limit is x approaches 0 of sine of 2x over x. So the very first thing I'm doing is I'm going to go to the mode, and I want to make sure that we are in radians. If not, change yours into radians right now. So then we're going to go ahead and I'm going to press y equals, and I'm clearing out our old function, and I'm doing sine of 2x divided by x. Okay, so notice how I close the parenthesis after the 2x. And if I press zoom 6, okay, it's going to graph it for me, and this problem says as x approaches 0. So a few things that we could look at. If I'm just looking at this graph, it looks like as we approach x of 0, our y value looks like it's going to be 2. Now, we can also use our table, so I'm going to press second window, and since we're approaching 0, I want our table start to be at 0. Our delta table is how much the table is going to change by, so I'm okay with 0.001. And then I'm going to press second graph, and I can see that from the left side and from the right side, it appears that our y values are going to be 2. So that's how we know that it actually has a y value of 2. Now, another thing that we can do, if I'm looking back at the graph, Remember, if I press trace, I can put in any x value I want. So if I did 0.1, it tells me 1.98. If I did 0.01, 1.999, 0.001. And I can see that it's getting closer and closer to 2. So that is the final thing that we could do to just kind of see where we're going. So hopefully this just gives you guys a good idea of how to use the graphing calculator. I would make sure that you guys know that really well. Practice graphing in your calculator. The better you understand how to do that, the better you guys will do on the test. Also, just a reminder that if you would like to bring a scientific calculator for the non-graphing portion, feel free to do that as well.